Hi, I'm Lukasz Fikus, and I want to talk to you about our new DAC. And in a series of presentations, we want to introduce various elements that combined made this unique product. And as we all know, LampizatOr always goes with tubes. So let's start from tubes, and then the tubes explain other decisions that we took in a design of this unique DAC. So our products dating 12 years back always had tubes, and this is the first time that we use tubes in a different way than previously, and the whole approach was different than with previous models, including the Pacific, Golden Gate, the Big Seven, Baltic and Atlantic. We started this project from absolutely blank page of paper and a blank state of mind. So we thought, what would we do differently than before to achieve goals that we could not achieve before? And that required new thinking, a lot of testing, R&D, prototyping, a lot of bird nesting and breadboarding. And the result is just a phenomenally pure and clean output stage. This is the analog output stage of our digital engine. We wanted this stage to be easily compatible with even most difficult next stage components, being a preamp, power amp, or integrated amp. So all three can be connected, because this is a fully functional preamp analog section with a remote control, volume control of the highest possible caliber. So you could treat this as a what we see on the top is a representation of the output stage. Let's make a pause.
It's fine. It's fine. Keep going.
The output stage, as I said, to be compatible with very difficult loads. By very difficult, I mean below 20 kilo ohms. Needs to have high current output buffers. And these power pentodes, you may say, wow, why a power pentode? What is it doing in a DAC? It's not an amp. Actually, we needed two things. We needed big size of tube, because the size of anode dictates a low density of electron stream, and that gives a very easy flowing and very natural sound. And we needed high current and low output impedance, and we achieved all these goals using the pentodes. But then, what are these two double triodes doing there? So you see 4 pentodes and 2 double triodes. That means 8 active components. Why 8? Because it's a balanced design, so you need 4 parallel identical streams. So each half of the dual triode, being 1 triode, and each pentode make a new combination of tubes, but it's not an input and output. What we did, we connected the triodes to both grids of the pentode, which has 3 grids actually. So 2 of the grids are connected to the triode in such a way that the triode is a differential amplifier between the grids. And you cannot consider or even measure these 2 tubes separately, because they become unity. They become like a hybrid of 2 different solutions, and they work in unison. So if the tube with 2 electrodes is a diode, and then you have a triode, and then you have a pentode, so this is an octode. It's like a 1 tube with 8 electrodes. And it's a very unique design, and I don't think that anybody ever used it, especially in any DAC. And that's what makes it interesting, is low distortions, high power, and extreme purity that allows the music to be heard without any veils or any kind of sugar coating, any kind of distortions or harmonics or what have you. It's super, super pure. And that's the key to the sound of Horizon. Today, on the second episode of Horizon Stories, I want to talk about tube rolling. We talk about tubes what they are and what they do. Now let's talk about rolling, which is a popular hobby these days because it allows the end user to get engaged with his product and seek a better match to his taste or his room, his amplifier, his liking, his music. By rolling tubes, we can somewhat alter the fundamental characteristics of the sound, while we supply the DAC with the most neutral, most balanced, most accurate tubes we can find. You may find it maybe too lean for your taste, or maybe you prefer something warmer, maybe you prefer something leaner, maybe you prefer something more cold in presentation. So rolling tubes allow to match exactly your taste. By rolling, I mean changing, you have to change all 4 pentodes together or both triodes together. Having said that, if you only use single-ended outputs, then these 2 tubes on the left, the 2 pentodes on the left, will be audible. These are not audible because they work in the negative phase of the balance signal. So theoretically, we can imagine that you have only a pair, not a quad of pentodes, and use them on the left-hand side of the DAC, and then your single-ended outputs will be affected. The right hand of the DAC can be populated with any tubes, the cheapest tubes, your old tubes, or even nothing at all. You can try nothing at all. Rolling tubes. The pentodes are the octal power tubes. So the socket is octal, and all octal power tubes have the same pinout, and they have the same heater voltage, 6.3 volts. Makes rolling much easier because any power tetrode or pentode will fit in this roller. It gets more complicated when we go to the small signal triodes, which are on the center line. These are, in our design, the socket is octal. So we designed the DAC for the 6S and 7 type of signal tube. From the octal socket, you can go with an adapter to any type of socket. The most popular are 12AU7, 12AT7, or in Europe ECC81, ECC82. Those have a particular pinout of the novel design. And then you can go to the 6922 or the Russian 6 and 6 or 6 and 1, 6 and 2, which have a different pinout also of the novel type. And then with these adapters, the adapters open the window to hundreds, if not thousands of tube types that can be fit here, and practically any tube except the highest amplification ratio tubes that are normally used in phono stages, those high amplification ratio like ECC83, 12AX7, they have amplification ratio of 100, which is too high here, but all other tubes can be used freely, and also the rectifier tube, which is an octal type of directly heated diode. This is 5U4G or 274B or GZ37, GZ34, and all the variation of the 5-volt directly heated rectifier can be used in this place. The synergy between your choice as a combination will give you the sound that you crave. And my last comment is that the power tubes, you should ignore the popular misconceptions or tags attached to certain brands or types, because anything you've ever heard or anything you've ever written about these power pentodes, it was said in the context of the power amps, and this is not an amp, and the application is completely different. It has a different operating point, different voltage, different application. So any comments about KT88 will come from the amplifier world and are not applicable here. So the character that you may find or Google as a common character of a particular, I don't know, a tungsten tube will not be applicable. So you have to find your own combination. And what can I say? Happy rolling. And we continue with our third episode of the walk through the Horizon DAC. And we were talking in our first episode about tubes in general, and the second episode was about tube rolling. So you can find them in the YouTube section of Lampizator. Now, the last tube I didn't mention is a funny little tube called Nixie. Nixie is a special tube designed for display of letters or digits, and it's been forgotten. Like our music tubes, our power tubes, rectifiers, they've been kept alive by guitar industry, by high-end industry, and they never really disappeared. Then Nixie became forgotten because we have LCD displays, and we have OLED displays, and we have LED displays, and all kinds of displays. So this thing that reigned in the display kingdom from around 1940s, 50s up to end of 60s slowly disappeared, and large stocks remained unused because there was no use for it. And some people build clocks for it, like fancy clocks, and it makes me angry because they deplete this wonderful tube that can be used in audio, and they build stupid clocks which could be made in any other way. Anyway, back to the Horizon. The first feature that strikes people when they see the DAC is the funny display. And some people don't even know what they are because they see 2 digits, and people don't realize that these digits are created from a tube. This is not a vacuum tube because it's filled with gas. So there is no oxygen, there is gas, and applying just voltage to one of the digits, all the digits from 0 to 9 are present inside, and they are kind of like transparent. So applying the 140 volt DC to one of the digits makes it glow. When it glows, it doesn't consume any heat or any current or any power. It just glows, and it's a passive device. So compared to LCD display that is commonly used and we use in our other Lampizator products, LCD display requires a microprocessor that runs the pixel display on a screen. So a microprocessor requires power, requires memory, requires a clock to run. So it becomes another noisy environment inside the DAC, where we don't like any other competition for noises. The only noise we have is our own clock, and of course we can deal with that. An addition of LCD display creates problems with grounding, with common grounding, with some noises traveling on the ground and feeding back to the DAC loop, etc., etc. So finding this Nixie display allowed me to create a display which is completely silent, doesn't have any clock, any processor, any current, any heaters, any special power supply. It doesn't even require any power supply because we can use power from any tube because it's only voltage without current. So it's sexy, it's cool, it doesn't break. We sold several hundreds of these displays and none of them ever broke. So it's a good indicator of longevity. They should last anytime between, 20, 30, 40 years. So we are very happy to have such a reliable and funny looking product. It makes us stand out from the crowd because a modern DAC, and this is probably the most modern DAC in the world today as we speak, despite being so modern inside, on the outside it looks maybe not nostalgic, but it looks like the from the era the tubes were present. So I'm very happy that people react nicely, and so far, out of hundreds of people in this room and in the show, nobody criticized the display as being silly, and I'm taking pride of being the designer of this display, so it's my pride and joy. I hope you enjoy the crazy Nixie tube. And in this 4th episode about Horizon DAC, the latest Lampizator flagship product, we will talk about the user interface between the listener, the user, and the DAC. And in the previous episode, we were talking about the Nixie tube. The Nixie tube that is part of our display, the information on display is very limited, but I don't feel like the DAC has to provide any information. By using your tablet, using your computer, your file interface, you see the name of the song, you see the duration of the song, you see all the tags, you see the file or the type of file, if it's FLAC or if it's WAV or IF, if it's streaming, if it's Cobbles, if it's Tidal. You know everything about this file. You know its frequency, if it's DSD 512, DSD 128. So we don't have to duplicate that information just to reconfirm what you already know. For me, it's more important that any file that you play will immediately play and have good sound on our DAC. So we don't need to inform you what we play, because we play everything that is, as we say, thrown at it. The user interface consists of 3 buttons and 2 digits. And we try to use these Nixie tubes knowing that they don't provide the amount of information like a color, touchscreen, or something like that. But actually we managed to squeeze from the 2-digit interface a lot of information. Let's start with a muting function. When we mute the product, it goes to 00, and we know that the muting has been applied, and it's by default when the unit is switched on. Now we can unmute, and we see the volume level. This is the 2-digit volume level, starting from 00 to in 64 steps, going to the maximum of 63 dB gain. On this same 2-digit display, we are able to show the number of input. We see input 03, 02, 1, and 8, and it will cycle because we have 8 inputs. So USB is on input 4. When we set input 4, we know that it's USB. So for this brief moment, it's displayed on the front, and then it defaults to volume level. Each of the 8 inputs will remember your volume setting for that input. So maybe you have a turntable connected with a phono stage, and maybe you have a reel-to-reel, maybe you have a TV going through the Toslink interface. On any of these inputs, maybe the requirements for volume will be different. So when we memorize them, each time we go to the input, we will have the same last used volume level. So that prevents us from going all the time defaulting to 0, or accidentally going to maximum and then blowing our speakers. So we have indication of muting, indication of volume level, indication of input number. We also have indication of bypassing the entire preamp section, going into straight tube DAC output with a maximum volume, and that is indicated by digit 63. We can go to 63, and that means the 63 means bypass of volume section. It gives us the most pure, most dynamic sound, but then we need to use the power supply of the amplifier, which may be and probably is of lesser quality than this volume control, which is of the highest possible caliber. So it's very rarely used by common amplifiers. Going back down, you can see that there is various speed. When we hold the button longer than 2 seconds, the speed of changing the volume accelerates to the maximum possible speed, and you can see very quick decrease or very quick increase, because the system understands that you are holding the button because you want to go very quickly up or down. And the last function of the display which we use is the countdown. When the unit is switched on, I can demonstrate by switching it off. It goes to standby and then to sleep. And when we switch it on, the unit will use a 30-second countdown in order to stabilize the tubes, go to the correct operating temperature for tubes, and also to establish connection between the computer and the DAC, because the USB sometimes takes a couple of seconds to recognize, negotiate the connection speed and the default driver for that given USB port. So this is the functionality of the remote, and also these 3 buttons can do everything from the front panel. So if you lose the remote, or if you forgot where you put it, or maybe the battery is dead, you can use these buttons to go up with volume or down with volume, select inputs, and then switch it on and off with a middle button. I hope that you find it as useful and as attractive as I do, because I think it's the coolest user interface on the market. Show, and we are taking opportunity to talk about the DAC, which just had its debut last morning, and so it's the first time that the general public sees our DAC, and there are many questions. People visit us and they inspire us to answer their questions in a video mode, so other potential customers or simply people interested around the world could understand what we are about and why we are so excited about Horizon DAC. It's our flagship, so it took some time to prepare the digital section, analog section, all the functionality, but what was also very important was the looks. We are not famous for the most attractive Italian style of design, so our previous products were always kind of Spartan, kind of form follow function, kind of industrial design, and people like it, and it became our hallmark, our unique look. So we didn't want to change the general style of the new housing. We wanted to maintain the Spartan and industrial look while giving you some hint of luxury and very good and strong, robust engineering that will provide a lifetime service and that will make you proud owner, and it will also break your back. I'm sorry, it's a very heavy product. So we started from abandoning steel altogether and abandoning all the metal bending, so it's all CNC. We started using big slabs of aluminum and then designing all the cutting and polishing and CSC routing and creating new surfaces. And it required changing the design from single piece design to a total design. So you design all the elements, including electronics, tubes, screws, everything is designed in one file in AutoCAD, and then you can put it together, and then you can blow it, expand your drawing, and then concentrate on aluminum, concentrate on PCBs, transformers, cables, sockets. Everything is in one design. So when it comes together, it fits, and the precision in our system is 0.01 millimeter, so 1/100 of a millimeter, which is about thickness of 1/4 of human hair. That's the precision or the grid on which we operate while moving every component and trying to put them together and see if they fit. And they do fit, so at the end there are no surprises, everything must fit, and there are no collisions between capacitor and another capacitor or a tube and a chassis. This precision allows us to build things in a virtual world, and then even we can rotate it in 3 dimensions and see where is the ventilation, and at every given moment we can see the weight of the product depending on how much aluminum we extract by routing. So these slabs are 1 inch thick slabs of aluminum. There are 6 of them, so the front, the top, 2 sides, and the back and the bottom. And perhaps the most important parts are the invisible ones, which is the bottom. What is new, that unlike in our previous products, we don't place PCBs on standing supporting these little stands. So that PCB is not flexing in a way from vibration or any force. Instead, we mill the place for a PCB as a frame within the 1 inch thick floor plate. That means that the PCB will sit in that hole, in that cavity, and the whole perimeter, the whole area around the PCB is supported equally, lying on hard aluminum. So there is no force or no vibration which can flex the PCB in any measurable way. That gives them very quiet and very vibration-free operation mode. So even the legs and footers and supporting stand is not so important. No matter how much the stand will vibrate, the PCBs will be in a quiet environment, mechanically speaking. So this is a very big advancement for us, and every component which we put inside the DAC is supported in that mode. So transformers, relays, power supplies, PCB, digital PCB, volume control, all the cabling and cable canals are routed and milled inside the aluminum, solid brick of aluminum, so to speak. And then another new feature is that we completely abandoned anodizing. In our opinion, the finish that we provide now is much more stable. Its longevity is practically infinite. You can clean it, you can polish it, you can wipe it with alcohol, you can wipe it with water, with soap, and no soap, or window cleaner. Doesn't matter. It's not going to be affected in any way. There are no fingerprints. There are no aging indicators. So 10 years from now, it will look identical with identical color, identical writing, and we believe that this is a beginning of a new era, where this new oven-baked powder coating with Teflon granules within the paint give us the best performance. And actually, I was worried that people are so attached to anodizing that they will react badly, but so far all the reactions are very positive, and people say, wow, this looks super cool, super professional. And probably in the future we will try to experiment with different colors. At the moment it's a charcoal black, which is most attractive and easy to combine with different colors of the top plate, because this top plate, which is the cover of the tube section and the shield from electromagnetic fields, this copper plate can be had in any color we want. So it's the only customization color that we will allow, giving us a possibility to have black or natural copper or deep red or any other choice of the customer. So this plate on the top will be replaceable, and it can be had in any finish imaginable. We will be very open to experiment with attractive finishes. The body, which is the very hard block that feels almost like a solid stone, this is just one color. It is a very attractive feature that many people appreciate, that our DAC is made without screws. So there are no visible screws anywhere, on the top, on behind, on the bottom, anywhere. So not only there are no screws visible, but those that do hold the piece together are invisible. They are covered by the footers, by the so-called legs. So you have to gain access to the bottom, remove the legs, and then you will gain access to the big pins that hold the whole piece together. And after unscrewing the pins, the chassis will open, and we will gain access to servicing or replacing a damaged panel, or replacing a module inside. So it is very easy, very quick. It's service friendly, but to the naked eye, it's invisible and completely concealed. It is especially in contrast to our previous designs, where screws were not only visible, but they were exposed, and we were proud of our nuts and bolts, making the industrial look very distinct. So I hope you like it. Its simplicity, its proportions, its golden ratios everywhere, and I think it's a timeless look that will look as good in 10 years from now or 20 years from now. It will not become obsolete because we're not following any short-legged fashion. The unit has the same size as our previous flagship Pacific. So in order to keep the same flight case and the same shelf space and the same requirements for assembly, we decided to keep exactly the same dimensions as Pacific, even though the different design makes it look slightly different. So some people look on the picture and they think it's small unit. It is not small. It's as big as we can get away with. If we could get away with a bigger chassis, we would use a bigger chassis, because internally it's completely filled and there is no space for anything more. Therefore, we measured the biggest components on the market which people accept, and we took the biggest dimension of the biggest components available, not counting, of course, the VAC statement amplifier. It's been the day 2 of our premiere, worldwide premiere, the first time that the general public can see and experience and hear our flagship DAC. And we had many people in the room asking various questions, so I'm trying to address all these questions in my video, blog. Many people are confused whether it's a preamp. Because first thing that people think when they see this product is that this is an amplifier, because they see a lot of big tubes and a massive chassis, and of course it's a DAC. So that's the first surprise. The second confusion is whether it's a preamp, or is it a DAC, or is it a DAC with a preamp. So let me address these issues, because I think it's important. We try to offer in this design as much as we can to address all the needs of a typical audiophile. So we wanted this to be like an entertainment center of your system. It's a central point. Not only that, the source where the music is becoming analog signal from all the digital files, it is like being born here. So it's very important that you amplify further down the stream, you amplify high quality music signal and not low quality music signal. So we believe that the importance of high quality DAC is paramount, and I would say that if you try to divide your budget, the DAC should be more expensive than the amplifiers. You can get away with simple, basic, nice amplifiers. With this DAC, you will still experience music better than with the best amplifier in the world with a low quality source machine. So is this a preamp? No, it's a central point where you can link all your sources of information, all your sources of music. So we have 8 inputs. So by using remote control or the input selection button, we are able to select 8 different inputs, of which first 6 are digital. Number 1 is Spdif, the Sony Philips digital interface, which was born as a link between CD player or CD transport without the full analog functionality. CD transport feeding the DAC with Spdif signal. That was the first link ever used in a DAC. Then it was followed very quickly by AES EBU, the American. AES means American standard, and EBU is a British standard. They come together and create a variation of Spdif, which is exactly the same signal, same source of signal, same syntax, same parameters in terms of bitrate and speed, except that the cable can be balanced, and in AES EBU, the balanced cable allow the user to use longer runs, where Spdif could be probably between 3 to 5 feet maximum, then AES EBU is up to 1 mile. That allows us to wire, for example, big recording studios, or even a feed at a concert venue from the stadium back to the recording track or recording booth. So AES EBU is only important for the distance, not important for the quality of sound, which is exactly, absolutely, totally the same as Spdif. And I would even say that Spdif on short runs should be better. The third one is Toslink. Obviously, there are many devices using optical link, so you can connect your PlayStation, your Xbox, TV. That's what I do at home. I connect my big TV with a Toslink cable, and I get all the feed from Netflix going directly to the DAC. In this mode, the TV is mute. It doesn't have the sound of its own, and all the music or all the audio part of the movies go to the DAC and then to my stereo system. So Toslink is again exactly the same as SDIF. It's the same waveform, it's the same bitrate, the same speed of sampling, is the same sound quality, but it's allows us to have opto-isolation from the next component. So if there are any problems on ground differences or potential differences or humming between TV and stereo system, that is eliminated by using of Toslink. And then it allows us to use long runs. Simple cheap cables go up to 10, maybe 30 feet. And then glass cables can go to up to 25 miles. So it's on, let's say it's infinite for our purpose. So Toslink is a very nice connection. I like Toslink. I'm much less against Toslink than most audiophiles who think that it's inferior. And my measurements and my testing and my listening sessions show that it doesn't have to be inferior if the input is designed correctly with high-speed power supplies and very good port, the optical coupling port. Another two interesting inputs are I2S. I2S or I2S, as some people say. It's a 4-signal connection that is connecting the source of data with the DAC. It's a very interesting connection, but also very difficult to implement because I2S is not a standard. There is no standardization between companies. So both the plug and then the cable can be different, can vary wildly, and also the data transmission protocol can be very different. It can be balanced, it can be single-ended, it can be low signal, or it can be high signal TTL. So we have 4 variants, and the mix of 4 gives us many permutations. And then we don't know what plug to expect and what pinout to expect. So going without standard is hit and miss, more or less. Many companies produce their transport and DACs that match together, but they don't care about other people because they don't encourage other manufacturers' devices to be plugged into their transport or vice versa. So we had to choose something. We have HDMI, which is just a convenient kind of cable and plug, and we have I2S in Ethernet cable, the RJ45, which is easy to manufacture by yourself. If you have a crimping tool, you can take any cut cable, cut 6, cut 5, especially the plenum ones with Teflon insulation. You can crimp the plug and use it as a convenient link. Having said that, I2S will not allow us to play DSD. DSD requires a lot more than I2S connection, so we need muting flags and we need DSD indicators of format. So this can be achieved only in USB module that has all the intelligence firmware designed to take care of pops and clicks and clock changes and format changes. So I2S I would recommend for PCM, especially high resolution, but generally don't expect magic. This is not a better format, it's just an alternative. That takes me to the last digital input, which is USB. Obviously USB became most popular. It works with every computer, be it Windows, Linux, Mac, anything you have that has USB port can be connected. And the Windows needs some kind of driver that we provide for free, and all the other operating systems don't require drivers, so it's very convenient. We just plug in, the transport recognize our machine, display LampizatOr logo, and negotiates the speed according to the file format. And our USB transmission allows to transmit and read and decode every file format existing. So you don't need to worry if it's compatible or not. Any file that is commercially used as a music carrier will be decoded properly without any fuss or any interaction with between the user and the DAC. So USB is by far our preferred format. It allows us to play PCM to up to 760 kilohertz sampling rate, DSD up to 512, and every format in between, and also allows us to switch between the format on the fly without any audible artifacts in the speakers. And then, interesting, so we can combine in our system a DVD player, CD player, satellite receiver via fiber optic, and a console game like what's called the Sony PlayStation, and digital broadcasting tuners, also CD transports, traditional CD transports, computers, streamers, any kind of like Raspberry Pi, little toys, toy computers. There is no problem. We haven't found yet a device with USB or any Toslink or Spdif connection that would not work with our DAC. What is interesting that we also wanted to allow people to use the slowly vanishing but still interesting for audiophiles devices that use analog signals. So if your system doesn't have a separate preamp, if you have just a power amp, you might want to connect to our analog inputs your analog sources. It could be a phono stage from the turntable, it could be your FM tuner, it could be a reel-to-reel tape player, it could be cassette deck, or maybe another, let's say, SACD player that you want to use. And SACD players don't have digital output, so they naturally only play via analog outputs. So any output which is so-called line stage or line level format can connect, and we accept RCA single-ended inputs, we accept XLR balanced, fully balanced inputs, and then they are routed through the volume module, and so you can choose by remote your different source, adjust the volume, and the volume will be remembered, so you can equalize between the DAC volume and your external source volume, so anytime you switch between the two, it's there is no jump in relative volume. So practically having this DAC allows you to use just power amps and not worry about anything else, because any device known by us used in the entertainment business can be connected and enjoyed with the same quality. There is one thing worth mentioning, that if you use line level sources of analog type, the tubes will be not involved, only the volume control section. The tubes are not required. The tubes are only used for amplifying the internal DAC signal, which is very, very weak. It's as weak as phono cartridge. So we have to elevate it to the generally accepted 2 volt level. And all the other sources are already 2 volt level, so we don't need to amplify them. So we can skip the tubes and have it straight, pure, clean as it is, as your Studer or your Tandberg or any kind of phono stage produced. Therefore, at the end of the day, on the output level, everything will be equally loud or correctly loud. So, with one remote sitting in your chair, if everything else is connected, you can have a freedom of choosing 8 sources and comparing them, or enjoying them alternatively, or listening to the music in the morning and to the movies in the evening. Doesn't matter. This is the only device you need for controlling, converting, and amplifying your signal. And I hope you will enjoy the high quality of this preamp DAC as much as we do. We were planning to make a 3-episode series about the DAC, and it turns out that 3 is not enough. So to talk about this amazing product, our pride and joy, our flagship, we went for the 4th, 5th, and now it's a 7th chapter, and there will be one more, number 8, and that will wrap up the brief history of the Horizon DAC. Episode number 7, we want to discuss a little bit the internal circuitry, and I wish we could have a small camera and all the lights and all the editing tools, but it's just a teaser. We will show the internals of the DAC when we broadcast from the factory, but here we can only talk about it, so I will try to use your imagination and use my limited vocabulary to explain what is inside, like why exactly this beast is 112 pounds before packing. It's very heavy, and we did not put stones or any lead inside. It's all, every gram has a justification, and we made it as light as possible. So we extruded, by using the CNC machines and tools, we extruded every piece of aluminum we could extrude to make it hollow, but it's still completely solid, like a rock chassis. The chassis must be strong to hold all the internals in transportation, in intercontinental flight, so nothing can be detached or broken or bent. It's also very elegantly made piece that is your pride and joy when you own it, when you put it on your rack. You feel that it's very solidly made and that it deserves the flagship status. But what's inside in terms of electronics? Let's start from power supply. We don't use any impulse power supply. It's an easy shortcut. It's a simple way to achieve your desired voltage and current. It's probably much cheaper than anything else, the impulse kind of switch mode power supplies. We decided to not use them for various reasons, sound quality being main reason, and then reliability, longevity, etc., etc. So everything we use in this DAC is traditional linear power supply, meaning that we need transformer, and we need a bridge, and we need a capacitor filtering network. The transformers, to avoid humming, avoid any kind of overload, avoid any kind of stress or distortion of the sine wave produced, the transformers are oversized. So we have 3 power transformers inside. Each of them is roughly around 100 watts. So we have 300 watts of potentially available power, even though we only use 65 watts at the end of the day. So there is some headroom and protection from going into the dangerous humming zone, because the transformer, when it's loaded correctly, is silent. When it's the load increases versus its core cross section, because the power of transformer is mainly decided by the cross section of iron. So as the load increases, it starts humming slightly, and then it starts buzzing, and then it starts overheating, and then it goes into the meltdown. So we wanted to stay as far away from the meltdown zone, you guessed right, as far as possible. So three transformers, 100 watts each. One transformer is dedicated only to the digital section. One transformer is dedicated to the tube section in all the low voltage needs, like heaters, like biasing and other the filament of the rectifier. Then high voltage, which is the most important in tube design. The high voltage that goes on anodes of all these tubes is made by the specialized EI transformer, so it's a traditional cubical shaped transformer, and it's supplying the 8 anodes of these tubes. 3 transformers means 3 times the 100 watt core, and then the copper. We have primary windings, we have screen windings, we have also secondary windings, those that provide precisely correct voltage to the various elements of the circuit. We have 17 power supplies in total, so there is 17 separate windings to avoid crosstalk, avoid sharing the load, avoiding overload, and generally this results in a beautiful sound, very clean and very transparent. 17 secondaries, this is something unheard of. Our best DACs from 7 or 8 years ago only had 4. So this is a big progress. It's an expensive progress. That's why this is a flagship. We can't cut any corners. So just to give you an example, just the USB module has 2 separate transformer windings to allow galvanic isolation between the grounds and between the signals, so that when we plug the computer environment and the USB cable is galvanically, means totally isolated from the DAC. So there is no ground loop, no noise coming from the computer, neither or on the 5-volt line, which we don't use, it's cut off, and nor on the ground line, which is connected but opto-isolated. And this is only possible if you have dedicated transformer with 2 windings. Digital section is super complicated. It's about 3 times the part count of the previous Pacific DAC, and by part count I mean complexity and sophistication of the digital, as we call it, engine, digital section. The digital section has 2 major areas of concern, 3 major areas of concern. One of them is receiving all the digital signals that we discussed in episode 7, so all the data formats and all the data inputs, all the data cables and all the plugs that are commonly used. They go through various stages of input receiving, and then managing this file, and then converting them to I2S, and then feeding them to the DAC section. Each of these tasks and each of these chips, and then there is also a microprocessor that runs the shows, so decides about all functionality, and opto-isolators again, and very high-speed data couplers. All that is separately fed from separate power supplies. There's 12 of them in the digital section, so makes it as clean as possible, and no 2 processes in the whole product share the same winding of the transformer, and hence the power supply. Of course, all the diodes are Schottky bridges, which are the cleanest, the most elegant diodes that one can use. And then there is the whole area is one giant PCB on the top, which is the analog section holding the tubes. Again, every function is separately fed from separate power supply. Every tube has a heater from separate winding and separate power supply. And there are also relays, muting circuits, and all the functionality for data for power slowdown as the on a switch on cycle, the voltage is rising slowly, the heaters are rising slowly. All this is managed by the microprocessor or by specialized circuits. So all in all, there is no complexity that we could possibly add to make it better. You could have another idea or another design, but in this design we use the maximum possible complexity of power supply in order to make everything simple, clean, and trouble-free. So, for example, any possible failure can only affect one line, and then it's very easy to replace or change or fix because we know what failed. So the resulting design is very quiet. No stethoscope, for like a doctor's stethoscope, can detect any vibration or hum coming from the DAC. It is silent as a stone. Whether it's used in a 230 volt environment or 115 volt environment or 240 volt environment. So it will not vibrate, it will not hum, it will not affect the microphonics of the tubes. It will never be overheated or overstressed. The power supply should give practically infinite longevity. All the transformers are first impregnated when they are after winding, and then they are put in vacuum chambers with special resin compound, and the resin penetrates the windings and also solidifies it as a stone, and then they are placed in a big iron cups that shield them from magnetic fields, and they are potted again and filled with epoxy resin. So the whole assembly is a 3-level impregnation and potting encapsulation, which is the maximum known in an audio design kingdom. So we think that we've addressed the power supply in a most high-end mode that you can possibly think of, and hence the product is our pride and joy, and it should last the lifetime as your flagship component and the center of your entertainment system. Thank you for watching. and I encourage you to see number 8, which we will deal with the rear panel and all the incoming plugs, cables, and in a final 8th episode of the description of our Horizon DAC, our most beautiful, most fantastic product of the year, which we show in Tampa, Florida. We just completed the show. It was a very good show, very good reception, a very good reaction from people. And people heard everything and they saw everything except the rear panel. We couldn't show the rear panel because it was on the other side. So I wanted to just briefly introduce to you the functionality of our panel, where all the connections take place. We decided to use one format of connectors. These are the Neutrik connectors, and Neutrik offers every kind of connector humanly possible, so we are able to source from one company every needed connector, from AES EBU through LAN RJ45, HDMI, and then the female XLR, RCA, male XLRs, etc. Every connector has a description, and as you see, it is divided into 2 sections. This is the digital section with all digital connectors. There is 6 of them, so we can choose on our remote. This is 1, 2, 3. I'm sorry, 1, 2, 3, 4, 5, and 6. And then we go to analog connectors. These are inputs. You can have analog input in a balanced form, XLR, analog input in RCA form, left, right, and then you can have output, is single-ended output in balance mode, and then for your subwoofer also balance connection to run on the low signal to run your subwoofer if you have any, and some people really need the subwoofer connection, so we don't need to use splitters, it's already there. As you can see also we provide a grounding post. The grounding post is galvanically tied to the chassis, so it offers safety if you touch it, and if there is any high voltage on a chassis, that will prevent it from happening. Also, some people like to use grounding stations or grounding blocks, where all the grounds of the system are brought together, so this is the one to use. And it's, as I said, it's connected to the chassis, but the internal ground of the system is isolated by a diode and a resistor. And of course the AC input with fuse drawer with a spare fuse inside, the main fuse inside, and a switch which will light up so to indicate that the power is on. Here is a description of the product with all the important data, and we do it per each individual piece, so it is engraved by laser, and if there are any changes it will be reflected here. We have a serial number on this kind of unique label that is printed only one piece for us, and this is impossible to remove or to alter, and the same label is applied on your diploma of ownership, on the certificate of authenticity. And the rear panel is solid, it's totally solid. It's 1-inch slab of aluminum routed for these XLR connectors. Of course, if there will be any variations of the functionality or new model or a similar model, we can put different connectors, because there is so many of them that we will never run out of needed openings. I hope everybody will find a connector that he needs, and we don't know of any device that could not be connected to this DAC, because this practically includes every known format of transmission. So here it is, Horizon DAC, and we conclude the 8th episode. I hope I didn't bore you, and I hope that you found answer to most common questions, starting from episode 1, going through all the different elements of design. And since I'm the designer, I hope I spoke in a informative fashion. So any more questions, please email us, text us, WhatsApp us, or come and visit us. We will gladly present you Horizon DAC. Thank you.